Welcome everyone to another quick update. I also wanted to summarize the AMD RDNA 2 Big NAVI event from I guess yesterday. Their breakthrough in gaming performance here on our open source enthusiast channel. I did not expect, so what did I expect? I expected that as bragging as NVIDIA usually is, I did not expect AMD to catch up on them, which doesn't matter too much. It's always good to have two or preferably even more strong players like Intel and AMD and so on. But honestly, I didn't expect them to catch up on NVIDIA's latest offerings. And for me, it doesn't even matter if it's 10 or 20% fast or slow, whatever. The only thing that matters for me is open hardware specifications and open source drivers. And I will not over what some people might say of that body. Buy there some stuff with open, with closed stuff and binary only stuff from NVIDIA. So from that point, from this point of view of Linux enthusiast and kernel developer and other maybe hopefully soon alternative microkernel and all our other low-level stuff of programming stuff here, low-level PS3, S3 Verge, Voodoo and Silicon Motion and Number 9 and all the other fun here, I would not buy something else. Why? Because if I update the Linux kernel or run another microkernel, I have to adapt this myself, and from that point of view, AMD is the only choice. So I'm totally relieved that according to their, as usual, nicely pre-recorded presentation here, they can brag and claim numbers as much as NVIDIA. So apparently they managed what even I did not expect here. Their proclaimed 50% improvement or even like 55% or something improvement, so that they match or at times surpass NVIDIA's performance, and also most likely maybe in biggest terms in their Infinity Cache there of whatever that even was, how many megabytes, something, lots of megabytes. We should check this off cache, maybe it's written, was it 128 megabyte or something? There was something, maybe, yeah, 128 megabyte of on-die cache, apparently dramatically reduced latency and power consumption, delivers high performance and stuff. Maybe the Infinity Cache has a big part to do in that. And so the other stuff looks as usual, so far only pretty presentation, because that's all we get. We also have this here, not only in 45% performance per watt over RDNA, and in total 3.25 effective bandwidth and so on. In terms of numbers, so what graphic card SKUs do we have? They announced the entry-level RX 60, or entry-level, the entry-level of the high-end AMD Radeon RX 6800 or X 6800 XT with 6072 and even freaking probably nobody expected RX 6900 XT, 80 compute units, all 16 gigs of GDDR6 and some pretty questionable, if not disgusting, performance in terms of clocking. It's like, yeah, what's the hacking? What's the freaking hack? Do you even specify here some maximum boost clock of 13? Like 13 is like, yeah, nearly never reached because in 2020 and our maximum boost clock is mostly bushed anyway. So they have maybe new, or since sometimes I don't follow this gaming stuff too much, but like effective real clock of, it's like, yeah, this is what you reach in real life if you're not interested in bullshit numbers of single compute unit, peak something, single task of cool system, yada yada. So these are the real world clocks. So basically this game clock means real world constant load clock, and this boost clock means like, yeah, you never see this, and maybe shortly sometimes spikes of something. 256-bit memory interface and all 128 whopping Infinity Cache. They have, of course, some proprietary stuff as per usual. Also, by the way, in the meantime, one thing apparently, the performance with AMD Zen CPUs might be higher. And why do we have so many drop frames? Not brought to you by failing Vodafone cable Germany stuff. Smart access memory apparently allows Ryzen 5000 processors on AMD B550 and 570 boards and an RX 6000 series graphic cards. An accelerated processing, 13% performance increase in one game at 4K and something. I read from some open source developer on some forum that this apparently is not necessarily this processor and this board's related. So what this is doing, and this is also why you're here for this channel and why you probably want to share, like, and subscribe. So this means, so this actually would also theoretically work on other boards and maybe Intel CPUs. What this apparently is using, this smart access memory, means if your system, Uncore, chipset and board supports very large I/O memory maps, so like more than 1 GB or something. Since there is some gigabyte I/O mem high something, whatever option high memory, yeah, whatever something. So theoretically, according to some Linux developer, whatever Intel chipset drivers, maybe it doesn't work on Windows with Intel, but according to open source developers, not necessarily limited to this marketing statement. But yeah, you need to read as so often of why does it only work with AMD Ryzen 5000 series. Is like, yeah, more than 1 GB. So probably this means like mapping, probably not entirely sure what. Maybe they map their huge more than VRAM, because certainly the VRAM should be fully directly mappable, I would guess, but we will see. And so not sure what they use. Maybe they use this for virtual memory. Who knows? We will hopefully see in the open source driver. And so yeah, what else do we have? DirectX, so also DirectX ray tracing, DXR. So this is, I guess, the first card. Do they have this here in, I think they had this here. Yeah, this is here, the 1RA ray accelerator. One YouTuber, I think it was so much to the gaming YouTubers, or sometimes YouTube recommends gaming YouTubers, and often I just also my hotkeys don't work because we run the latest and greatest and future of Wayland desktop, you know. That is of course that here. So one gaming YouTuber, maybe Jay's 2 cents or something, said incorrectly said that so much to be careful what kind of fake technical news, and probably want to subscribe to some real developers. I immediately wondered when I watched this last night that he said it doesn't do ray tracing on hardware, and only like he said something like ray tracing is only implemented through DirectX 12 something on an API level or some. It's like, what? But yeah, so according to this website here, AMD RDNA 2 compute unit is an implementation of high-performance ray tracing acceleration architecture known as ray accelerator. The ray accelerator is specialized hardware that handles intersection of rays, providing an order of magnitude increase in intersection performance of comparing this to software implementation. Apparently 1 RA ray accelerator per compute unit, of which, of course, you have between 60 and 80. Pricing-wise, do they have the pricing? So pricing was like $449. Where are the prices? Do they have even? Don't they have the pricing here? At least they have this. I really wish they would have this. Or do they have dollar? It's often a little bit. Here they have pricing. Why should they put this into the table here? So pricing begins at $579 apparently, $649. And $999 for the 6900 XT. Probably as also seen here at the end in this video, probably wherever this one, but doesn't really matter much. Also, you need to be careful with the slides. Here is the 6800. performance, and they have here something that is as stupidly named as the previous RISC-V unmatched stuff, and that is, I think, Rage. Was it Rage? I think it was Rage. They have a Rage mode, not to be mixed with ATI Rage. This Rage mode, at least on Windows, allows some automated overclocking as per usual. And I think I saw in the fine print that 6800, also yeah, you see you constantly need to go back. Yeah, 6800, I think the 6800 base slides did not use Rage mode, and the XT slides used Rage mode or something. Yeah, one click here just was mentioned, one click overclocking. So as per usual with the diagrams, highly confusing. This is as cool as it is. So apparently, also, by the way, I think we had here somewhere, but right, where would be the performance numbers of, do they have here, oh, this is not competition, somewhere they compare themselves with the competition. I think, of course, you need to be as careful. Here's also something, is it, okay, as usual, as per Intel and NVIDIA, you need to be careful with the numbers. And here's NVIDIA RTX 3080. So yes, so this is probably what I was looking for, comparing an RTX 3080. Again, no open source drivers I don't buy. So totally relieved that our preferred open source friendly and mostly register level documentation publishing, I hope they continue to do this for this. So totally relieved that our preferred and open source neutral vendor, and I'm not a fanboy here, it's just like I learned back in the day of ATI and then later AMD, I just prefer when a company actively supports open source, and then of course I become a fan naturally due to, hey, want some register level specification, and hey, want some open source driver here and throw it in, and this is open source support and not some binary only blob. And it triggers me very much, all these NVIDIA fans who think NVIDIA is usable on Linux as long as it's not in the mainstream kernel, and in Mesa don't call it Linux support because it's not open source in there. So this is really cool to see, and certainly something I will hopefully be able to report some first-hand experience, because I'm rocking here some really aging CPU of Neo, what is it, Neo Fetch. I'm not making this stuff up. All these live streams brought to you by a freaking entry-level RX 460, which I think is the same as 560D or something of this. So yeah, I know what I was waiting for. Could live with that. Certainly can't do high-end development with that, but at least it's good enough for YouTube live streaming. Last but not least, so what else is new? To summarize and bring the summary home and stuff. Again, some proprietary terms of DirectX 12 Ultimate support with DirectX ray tracing, DXR, variable rate shading, and yeah, ray tracing as seen, Fidelity FX, open source toolkit, also yeah, open source toolkit, AMD GPU open something, and so what this variable rate shading, also funny how they stretch the marketing texture of having this twice. So they have this here, and then here again dynamically reduces the shading rate for different areas of a frame, so that not require high level of visual detail, delivering higher levels of overall performance with little to no perceptual changes in image quality. That is an actually interesting feature, and this kind of things are, for me as a software guy and developer and stuff, interesting to look into and experiment more and so on. Direct storage support, future direct storage API enabling lightning fast load times, allegedly high quality texture. Maybe this is what, although it's probably not what they need, some more than 1 gigabyte or whatever. Interesting to see how this is coming to Mesa, if at all in one, and hopefully it does. And also, yeah, this kind of stuff. What really triggers me is also this Radeon anti-lag stuff here. I really hate when they when they don't tell you how this works on a software and hardware level, like up to 31 reduction in lag, it's like, how the freaking heck, how? I really wish they would be more disclosing of like, yeah, it's like magic, black box, whatever. This is the thing, so much to not being a fanboy, but looking at this and it's like, how the heck does it even work? What do they do there? This, of course, is a Windows thing. And if you know details how this works, then let me know. What else do we have here? Also, yeah, for us, more like game streaming accelerated. It's like, yeah, that means VP9, AV1, and HEVC. I hope they don't get sued as Lenovo. Previous video of currently Lenovo ThinkPads not for sale in Germany because of X264 licenses. So the MPEG patent mafia stuff, so let's hope they don't take this from the shelves in Germany as well. But otherwise, for us, for live streaming, I hope this, I think this was already wired up for some Raven Ridge APUs. Anyway, as seen also for the YouTube, what do you need this also for? You also need this for accelerated YouTube watching of hardware accelerated VA API, saving battery, especially on your mobile SKUs here for modern, because certainly in 2020, as per my previous videos of all the Firefox and hardware acceleration stuff, you don't even get this, even if you patch all the stuff together, because YouTube just delivers AV1 to you, and if you don't have AV1 accelerations, then you don't get any, yeah, if you don't have this in hardware, you don't get any precious VA API enablement there anyway. So I think this is basically mostly it. So yeah, from the performance, again, really nice to see. This might be a little bit overpromised as per usual, but I'm also looking forward to be proven wrong there. But I have the impression maybe, as per usual, take some marketing slides. For me, even if it's, I said this in the beginning, plus minus 20%, whatever, something, just give me the best open source support. And then you have already won me. What do I care if this is 2, 3, 4, 5, 6% of frames, less or more, if I have superb Mesa support there. I think this is all feature-wise. Again, probably want to share, like, and subscribe to see this here in future YouTube live streams and doing some Linux testing. Let's see what comments we have, which were some. So yeah, 8.7. Anyway, neighbors watching over this shared Doxer scale stuff. So all this 3000 frames not brought to you by Vodafone failing DOCSIS cable stuff here. Roland Ruckerbauer says current GPUs use 256 megabyte PCIe bars. Just discussed it with a couple of people at work. Let's actually check that. So to rise, this is that LSPCIV, and so let's see our also stupid mouse will support. So that would be Radeon whatever, and do we have here memory 256 megabyte? You are indeed right. Interesting. So that means that it would need, okay, or maybe they DMA it in. Interesting thought. I've not thought about this. This comes from only. So yeah, maybe this is that. Maybe I should actually check my BIOS if I have some, or maybe this older GPU doesn't even support this. So yeah, AMD here you have this RX 460 or 560D, whatever stuff. That's interesting. So what this means, so this is coming back to this, what do they call this? I really hate this stupid marketing naming. It's like vendor proprietary call this something. Where is even GPU? That, and so this boils down, what this means is what Roland wrote there is, where would this even be, and why, right, I clicked here on this marketing slot on Intellect, this is why we don't have this anymore. So this is, and I actually need to go really soon, Smart access memory. So the smart, in other terms, what Roland just discussed there with a couple of people at work there. So this, as I said previously, this means if your platform and BIOS supports large gigabyte-sized I/O maps. I actually never look into this. This comes from doing a lot of low-level stuff, Verge, Voodoo, Silicon Motion, Link 3D, Number 9, Revolution 3D, and a whole bunch of other stuff, and more coming, and P3 RSX. So this boils down to smart access memory, means like just fully, like all 16 gigs directly mapped to the processor, of not DMAing or other memory management unit, DMAing or other banked memory switching of your freaking 256 megabytes. So this is probably some old-fashioned, probably there never was a real technical reason, I would guess, except other chipsets and stuff previously didn't support more, I guess, maybe, or still supporting garbage 32-bit stuff of booting with a BIOS and Windows, yada yada, the good stuff. So yeah, smart access memory, aka fully mapped VRAM to fully directly mapped VRAM to the rest of the system stuff. This is what you hear from, not other people's 2 cents, but really technical hard details, because that's what we love and are here for. Otherwise, Evergreen says, hope they fix some. This probably virtual VI reset. Interesting. Interesting that you say that, but are there not workarounds for that? Having to do kernel patching, such a pain in the ass. Yeah, as previous videos we sent in stuff, nobody cares. So memory thing is related to how large memory you can allocate for buffers, so you don't have losses. I think this is slightly different. Yeah, Rilo, as discussed, I think this just means, as Roland points out, not allocate, but this means directly mapping it, the whole bar here, as per, where also this is wrong, as per too many key bindings of, as I said, I think according to an AMD open source engineer I read on the forums, this is just directly mapping the whole memory base address to stuff of whole VRAM there, and not allocations, but directly mapping that. Mark writes, fun fact, NVIDIA seems to be getting rid of smaller GPU dies in their lineup, going with GA chips something, and interesting, but not really interested in NVIDIA. Also, NVIDIA not hating NVIDIA, except, right, you know my love and hate relationship with open source unfriendly companies. But as I disclosed previously, we wanted to do with a customer to do an embedded Linux stuff a decade ago with our fine company that is Exacode here, and rewrote NVIDIA in 2008, and we wrote their original message for the current engaging project. We need some solid 3D support in our portfolio. Also, 2008, right? How long do we do this, and how much industry contact and knowledge and stuff. So we write them, at that time I had over 10 years Linux experience. It's like, and a real company to back this up. And I didn't even ask like, okay, give this without NDA. I even knew NVIDIA, certainly with all the stuff. And I just wanted to check for potential projects, you know, with the usual car stuff here in Germany, and you get the idea. It's like, hey, can we do this? So I write them, certainly I can't say yes, I need some NVIDIA stuff. So for portfolio and upcoming project inquiries here, kindly ask, right, how do you as a small company deal with big companies? Like, hey, kindly ask your possibility to, I even begging you to sign a freaking NDA to receive register level specification support from NVIDIA latest integrated embedded SOCs like Tegra at that time, our board support offerings. It's like, what answer do you get? 22nd of July there from there. Did I edit the name? Maybe I edited the name away. How is your Windows CE experience? We are not supporting Linux on Tegra. It's like, hey, that went well, right? Where's Windows CE today? And thank you. This is what commercial embedded Linux companies get support from NVIDIA in 2018 and probably today. So yeah, NVIDIA, you only get one figure from me until you fully disclose your proprietary and probably full of bugs, hidden silicone. So Marcus writes, speaking, they're rebooting the launch with a slightly beefier card based on the expensive chips. As far as he heard, board partners are furious. I mean, it's also NVIDIA. I heard that NVIDIA is totally screwing the board partners, which bringing state-of-the-art cards out first themselves and cashing in all the early fanboy sales and only having the NVIDIA board partners. So not only is NVIDIA screwing over the open source people, but also their own board partners, according to what I heard and how it looks. Laptop stuff, let's do it for hybrid graphics. They even had support for up to 8 gigs of GDDR6 direct storage. Every shows assets on the drive stream directly to the VRAM bypassing the system memory. Yes, writes Jalulius. Probably, I also, technical details, right? It's always so much marketing stuff. So, Jarul writes, direct storage API allows streaming assets on the drive stream directly to the VRAM. So I guess maybe that means OS support for like not DMAing first, like NVMe DMAing from the NVMe controller, like PCIe attached storage. First direct memory access, bus mastering this into the system memory, and then when you get the interrupt, hey, the data is there now in memory, and then DMAing that with a GPU driver back into the VRAM, but maybe directly, probably in 2020, direct bus mastering from one peripheral, PCIe attached peripheral to the other in terms of directly, hey, NVMe controller, give me this blocks, and so DMA that to physical address of PCIe stuff of E1000, whatever, something I would guess, which is probably also what you want this fully mapped smart access memory for. Additionally, Crime Time writes, unfortunately, it's like Big NAVI will still require firmware with AMD GPU work properly. Yeah, I mean that you need firmware to load in. It's like, yeah, okay, fine. Maybe one day in a decade, like RISC-V, we liberate this, or would be cool to have fully firmware. But in contrast to what some people believe when they start flame wars with me on some popular forums, I'm not that religious in that terms of. For me, firmware on the device is fine as long as the vendor supports it properly. And anyway, at some point, if they release firmware that it's mostly working, and if they later fix some bugs, not like unlike the bloody Microsoft Surface that up to this date Marvel never, it has some USB maybe some network auto suspend power issues. So as if this bloody Marvel firmware wants auto suspend, it doesn't work until the next reset or something, which is so thanks for that bloody firmware. So that certainly is not cool and closed firmware that never gets fixed, but I'm not religious, so yeah, it would be cooler with open source firmware, but as long as the single address-based monolithic Linux kernel driver stuff is free without blobs, and we can fully debug that, and you send commands to the firmware and it executes this, I'm sort of mostly fine with firmware in the peripherals. But yeah, the more open, the better, certainly. But I'm not a religious fanatic there in that space. Carlos can explain firmware like AMD is loaded GPU when initializing the boot. The GPU does have firmware already in itself. Maybe not all. Maybe this firmware is just enough for boot bring up. So often the firmware anyway needs to be loaded for full firmware, like supporting 3D and video and code stuff. And Roland writes, he can imagine mapping the whole space will be advantage with memory prefetching and security implications. Let's not think about that. Well, I think if this currently is always DMA'd in a banked way or something. It's not only prefetching, but certainly I didn't even realize that that is an interesting thing to learn here. But I would also say this has in general the whole not banking or otherwise DMA or whatsoever. Certainly a lot of managing like synced bank VGA like in the 80s. So certainly, yeah, would actually be interesting to see. But unfortunately, the Linux kernel Mesa code is so large, it's probably not easy to find it in there. Anyway, so that's for the summary. I hope you found this interesting and learned something. Don't forget to share, like, and subscribe for more content like that and tests to come and other open source and tinkering and programming and stuff to come. Carlos writes, Windows loads a firmware into the GPU too. Yes, of course. Otherwise, the NVIDIA driver will just do it. And usually the firmware is the same. So a lot of firmware in Linux is extracted from the Windows driver. And often, even if the vendors supply it, usually it is the same. It's only rarely that it's another firmware. So of course, the firmware is there in the card to make the GPU stuff function properly. So Windows or any other OS needs to load it just the same. It's not a Linux thing. Carlos, right? Is it the same? Usually it is the same, not necessarily. But if you have other, for example, maybe there was back in the QLogic SCSI days, other Windows, maybe they optimized or written other for Windows bugs or whatever. But often if it's not from companies, but open source people reverse engineer and write it, then they extract it, they capture with IO tracing or reverse engineering and decompiling the binary and extract the exact firmware, the firmware as used in the Windows driver. So yeah, but if the company supplied, it makes no sense for them to develop firmware twice. So if the company supplies this, usually they of course only have one firmware and just supply the same. Otherwise, why make double the work and extra work if, yeah. The BIOS is code that runs on your CPU, so that is like a small driver that enables basic input-output. And the firmware, so the BIOS runs on the host CPU and the firmware runs on the device CPU stuff. But that's it for today, and I hope to see you next time.